get started. Good morning, everyone. So yesterday we reviewed what you learned in first year macro, 3 key concepts in macroeconomics. Today we'll begin with our first topic in intermediate macroeconomics. So technically, our journey of intermediate macroeconomics begins today. What we'll do today is, as I said, we start with the short-run macroeconomics. That is, we want to focus on the short run. And here we developed the so-called ISLM model. What we'll do today is we'll provide the first building block of this ISLM model, the first building block. That's the IS curve. We'll cover the textbook chapter 3 and a bit of chapter 5 today. We discuss output, investment, and saving. There are 4 specific topics. We'll first review the GDP components from the expenditure side, and then we look at goods market equilibrium condition, and we'll show that this equilibrium condition can be represented as another condition, that's the investment saving approach. And lastly, we provide you with the formal IS curve. We want to endogenize investment demand, and then you see what the IS curve look like. So first, GDP components. Yesterday, we discussed 3 ways to calculate GDP. Now, from the perspective who demands this output, who demands all these goods, we have a way to represent GDP as the following 4 components. That is, GDP is composed of consumption demand, that's the purchase of goods and services from consumers, right? And the purchases of capital goods from firms, and the purchases of goods and services from government. And lastly, imports, exports. That is, we have to, our consumption, including iPhone, these are not produced in Australia, right? So we have to subtract this part from our GDP. That's why we subtract imports. But foreign people might want our goods, like the Australian UGG boots, right? It's really popular outside Australia. So these type of goods are produced within Australia. So it's part of Australian GDP. That's why we add exports. So to give you a bit of more information, 4 components: consumption, investment, government spending or government purchase, and net export. This consumption is quite intuitive. It basically refers to the goods purchased by consumers, goods and services purchased by consumers, and these are the daily consumption that we have. And investment is a bit tricky. Here, when you hear the term investment, you might think about financial investment. But this investment is actually not financial investment. It has nothing to do with your portfolio at your bank. Rather, this investment refers to the purchases of capital goods. That is, if you open up a firm, you want to maybe buy some equipment, buy a plant like that type of purchase of capital goods, this is part of the investment demand. And the building of new houses is part of investment as well. So that's the second component, investment. And the third component, government purchase. This part is what the government demands. For example, if the government chooses to build a new hospital, a new school, or a new freeway, so this will be part of the government purchase. Notice the government purchase doesn't include transfer payment. What is transfer payment? For example, I don't know if you receive any government transfer payment, but I do. My daughter goes to childcare, and I receive childcare rebates from the Australian government. So this part of transfer doesn't represent any new production of goods and services, right? So this part is not part of government purchase or government spending. And lastly, net export. This refers to exports minus imports, because export is part what Australians produce, but imports are not. What we consume include imports, right? Like your iPhone or whatever you import, whatever you consume from other countries. That's part of consumption, but we should subtract that part from our GDP, right? That's why we add export minus import. So take a look at this example. That's the Australian GDP in 2011. You see that in total it's about $1,335 billion. And these four components, so far GDP, consumption is still the largest component among the four. So if you think about GDP, it can be decomposed into consumption demand, investment demand, government demand, and net export. Consumption is still the largest part, about 56%. And what's interesting is notice that in that particular year, Australia has a slight negative trade balance or net export. That means what? We import a little bit more than what we export, right? Australia has a pretty good, nice net export in the sense that it kind of fluctuates around zero. So sometimes we export more, sometimes we import more. And there's this last category that I put on the previous slide as well. There's this inventory investment. We'll ignore that in our lecture. This is a very tiny part in GDP. This basically refers to a part that firms produce, but they cannot sell, this kind of inventory investment. We'll ignore that. It's only like 0.3% in GDP. Now, why do we want to see this? It's because we argue that one very important assumption throughout the first 3 weeks is that we want to understand short-run macroeconomics. What is important in the short run? Economists find that in the short run, aggregate demand is more important. That is, we will abstract from the supply side of the economy. We'll assume for the first 3 weeks that no matter how many goods the economy demands, it can always produce that amount. So that is, supply side is silent, is quiet. We assume that supply side is quite passive. Now, no matter how much you want to consume, no matter how much government wants to purchase, it will always be produced. So the supply side is not an issue. And the second assumption to build up our model is that you can think about whether this is reasonable or not. If you think about the production in the actual economy, there are like apples, oranges, phones, computers, so many different products, right? But to look at this aggregate demand, we kind of assume that there is only one representative good in this economy. That is, we assume that economy-wide, we have this kind of one representative good, and we will that in the short run, the aggregate demand for this particular good is the key determinant of aggregate output. So that's what we assume for this model, the ISLM model, the short-run macroeconomics. Assume there is one good in the economy. Assume that the supply side is passive. The economy can always produce whatever is demanded in the economy. And then let's look at what determines this aggregate demand. Now, from what we just introduced, this aggregate demand in this economy, we use this notation, this capital letter Z, to denote aggregate demand. By definition, it has four components. So who needs Australian goods? These are consumption demand, this capital letter C, investment demand, capital letter I, and government purchases or government spending, this capital letter G, and lastly, net export, that is export minus imports. There are like four components of aggregate demand. Notice that we'll introduce a few equations, but this one is kind of an identity in the sense that we define aggregate demand in this way. There are four components of aggregate demand. It's defined as the sum of consumption demand, investment demand, government spending, and net export. And in what follows, as I said, we start from a closed economy. We don't want like imports, exports to complicate things for now. We assume that we have this export equals imports equals zero, so that aggregate demand is the sum of consumption, investment, and government spending. So far, so good. We are trying to understand in the short run what determines aggregate economic outcome, and we argue that in the short run, demand is more important. So let's look at what aggregate demand is. So this is the aggregate demand. Z is defined as the sum of consumption, investment, and government spending. Now, let's look at each component one by one. this consumption, what determines consumption? If you think about it, what determines your individual consumption? Would you spend more if you have more income? Is that reasonable? So if you have more income, you want to buy more goods. Is that reasonable, right? So that's exactly what economists kind of assume in the first place. That is, from the individual perspective, generally consumption is proportional, is positively related to your income. Then, in the aggregate sense, we assume that aggregate consumption is a function of aggregate income. But notice that's not aggregate income, but aggregate disposable income. That is, if government collect tax T, because we have government here, right? Government needs revenue. Where does the revenue come from? From taxes. So this Y minus T is what we call the disposable income. That's the income that's left for consumers, for every Australian household to consume. And we make a behavioral assumption of the consumption function. That is, consumption is a function of disposable income. In particular, the more income there is, the higher the Y, the more consumption there will be. That is, people consume more. In aggregate, people consume more when they have more disposable income. That's the behavioral assumption we made about the consumption function. Not too bad, right? So consumption is an increasing function of disposable income. Disposable income is total income minus taxes. So here is one very simple example of the consumption function. That is, consumption is a function of disposable income. Moreover, it's a linear function of disposable income. Consumption equals what we call this autonomous consumption. Yeah, C0 plus C1 times disposable income. C1 is called the marginal propensity to consume. That is, if you have $1 extra disposable income, how much more consumption you will have. Well, normally this C1 is less than 1. That is, if you have $1 more disposable income, you won't spend probably all of it. You want to probably leave some, just consume part of it. That's why generally the assumption is that C0 is greater than 0 and C1 is between 0 and 1. You will consume part of your extra disposable income, but not all of it. That's the consumption function. Graphically, this is it. What we do is we use disposable income on the horizontal axis and consumption on the vertical axis. How to represent a linear consumption function? Well, it has a positive slope, right? This autonomous autonomous consumption, C0 here. That is, even if you don't have any disposable income, you still need to consume, right? This is the part that you have to consume. Even if you don't earn anything, you have to eat every day. You have to consume something. This is the intercept C0. And the slope is given by this marginal propensity to consume C1. It's between 0 and 1. So that's a typical consumption function. It's linear. It has a positive slope and a positive intercept. Now, what about the other components in aggregate demand? We argue that there are 3 components in the closed economy: consumption, investment, and government spending, right? Let's keep it very simple to start with. Consumption is a function of disposable income, but let's assume that both investment, government spending, and taxes, these are all exogenous for now. What does it mean by exogenous? In economics, we use this term quite a lot. It means these variables will be taken as given, like no other variables will change these. These are taken as given. We assume for now, investment, government spending, and taxes, they are exogenous. We'll see towards the end of today's lecture that we'll make investment endogenous. That is, something else will determine investment is not exogenous. But for now, to start with, let's assume investment, government spending, and taxes, they are all exogenous. And in particular, government spending and taxes, they are related to fiscal policy. We'll talk about that later as well. it will determine government budget. And for now, let's take all these as given. We are ready to derive the equilibrium condition in the goods market. First, remember what we have assumed is that in the short run, aggregate demand is very important. Whatever determines the aggregate economic outcome, we think it is aggregate demand. That's why the equilibrium condition in the short run is aggregate demand, C, should determine aggregate output, Y. So we have a few equations by now. The first important bit is the definition of aggregate demand. C is the sum of C plus I, C, I, and G, right? That's the first definition of aggregate demand. The second equation that's important for us is the consumption function. That's a behavioral assumption of consumption behavior. And the third important bit is this we call an equilibrium condition. That is when goods market is in equilibrium, we have aggregate demand determines aggregate output. That's Z equals Y. And what is Y? Remember we argued that when you calculate GDP, you can do it from the income side or production side. So this Y is also aggregate income, right? And then remember that this C from the identity, right? We argue this is the sum of C plus I plus G here. And we also learn that it's reasonable to think that consumption is a function of disposable income. And disposable income is itself aggregate income subtracted by taxes. So what we have done so far is we find out if the goods market is in equilibrium, that is aggregate demand equals output, what we have is this is the aggregate demand, right? In equilibrium, it equals aggregate output. Aggregate demand determines aggregate output equals Y. And here we are left with what? One equation, this one, and one unknown, right? The only unknown here is the aggregate output or aggregate income. We'll use the term aggregate output and aggregate income interchangeably because they refer to the same thing, Y here. And is that magic? Actually, no, because what we have is, so far we have one equilibrium condition and one unknown. That's the aggregate output. We have assumed that taxes, investment, and government spending, they are all exogenous. From this, we can actually solve for this. We can solve for the aggregate output in equilibrium. This is the equilibrium output in the short run. Demand determines aggregate output, and it's a function of these parameters in the consumption function, C0 and C1, taxes, investment, and government spending. Graphically, there's a nice way to see this solution because we have already looked at the consumption function, right? Consumption function is linear. It has a positive intercept and a positive slope. And moreover, if you look at aggregate demand this way, right? So this is the expression for aggregate demand, and it is also a function of aggregate income in the following way. We can collect terms that relates to aggregate income and not relates to aggregate income in this way. There's a minus plus I plus G plus C1 times Y. Right? What I did above is basically I collect the terms without Y and with Y. It turns out aggregate demand, this Z thing is also a function of aggregate income. And it's a linear function, right? It has a positive slope here. This is what we call the autonomous spending. That is, even if when income is zero, you still have this spending here in the economy. It's a minus sign here. That's autonomous spending. And we also have a positive slope, that's C1, determined by marginal propensity to consume. Now, what's the equilibrium condition? This is the aggregate demand, positive line, right? Upward sloping line. And remember, the equilibrium condition is this aggregate demand determines output Y. So notice this horizontal axis is income output Y, and the best way to see this is to draw a 45-degree line, right? This is where this orange line, on 45-degree line, this is where you have aggregate demand equals aggregate income or output, right? So the intersection of the aggregate demand and the 45-degree line give us the equilibrium in goods market. This is where aggregate demand here, aggregate demand from the gray line at this intersection is given by here, right? Equals aggregate income. That's on the horizontal axis. The 45-degree line makes sure that these two are the same, right? That's the equilibrium condition. The intersection of aggregate demand and 45-degree line give us the equilibrium in goods market where aggregate demand equals aggregate income or aggregate output. So are you happy so far? There's a graphic illustration of the equilibrium in goods market. Aggregate demand equals aggregate output. Okay, let's take a further look at the implication from this goods market equilibrium condition. Suppose there's an increase in autonomous spending, this big part, like C0 minus C1T plus I plus G part. Suppose government increases spending by 1 unit. What's the implication on aggregate output? Well, the first question for you to think about, if government spending increased by 1 unit, it should have a positive impact on aggregate output, right? Because after all, aggregate output should be the sum of consumption, investment, government spending. If government spending increased by 1 unit, then it should lead to some increase in aggregate output. Now, the question is, will that lead to 1 unit increase in aggregate output or maybe more? What do you think? Well, mathematically, it seems that if this term G increased by 1 unit, what happened to aggregate output? It will increase by this 1 over 1 minus C1 unit, right? Just mathematically, this is the answer. What's the implication? It means that if government increases spending by 1 unit, it will lead to an increase in output by more than 1 unit. In particular, this extra increase depends on the size of this C1, right? So what's the intuition? Well, this is a good way to illustrate what's going on here. Graphically, this CZ gives us the aggregate demand. And if there's a 1 unit increase in government spending, where does government spending enter into the aggregate demand? Back to this one, look at here. In aggregate demand, government spending is here, right? It's part of the intercept, right? It doesn't affect slope at all. Slope is C1. So the increase in government spending will shift up this aggregate demand schedule, right? So slope remains the same as C1, but intercept increased by 1 unit. So this is that 1 unit that we talk about. The increase in government spending will shift up aggregate demand. It leaves the slope unchanged because slope is determined by C1. Now next, is that all? Obviously it's not, because from that previous equation on aggregate output, we know aggregate output increased more. What's going on here? Notice that, think about it together. when government spending increased by 1 unit, the direct effect is that output will increase by 1 unit, right? That increase in demand directly leads to 1 unit in aggregate income. But that's not the end of the story, because something else in aggregate demand depends on aggregate income. What is it? Consumption, right? I heard some of you say consumption. Exactly. If there is a 1 unit increase in aggregate income or aggregate output, then aggregate disposable income will increase by 1 unit, right? And that means what? Consumption will increase by C1 times this 1 unit, right? From the marginal propensity to consume, here, if the income increased by 1, then you will spend C1 extra, right? That's the marginal propensity to consume. That's exactly represented by the CD part. That is, if the 45-degree line gives us the increase in aggregate income, this is the 1. The increase in aggregate income, that's the direct effect of this increase in government spending. And this gives us more disposable income and hence more consumption. That is given by the CD. That's C1 times 1. Because here the slope of this aggregate demand is C1. Now we know that the direct effect of an increase in government spending is that aggregate output increased by 1. But since aggregate output increased by 1, aggregate income increased by 1, aggregate disposable income increased by 1, from the marginal propensity to consume, we know consumption will increase by C1. But that's not the end, because when consumption increased by C1, aggregate output again increased by C1, and aggregate income increased by C1, and aggregate disposable income increased by C1, and hence aggregate consumption will increase again by what? C1 times C1, right? And this will continue for many, many rounds. That's exactly what's going on, what's written down in this slide. That is, there will be many rounds of impact. The first round is the increase in government spending give you 1 extra output, and that translates to 1 extra income and 1 extra disposable income. That will give you C1 extra in consumption. That second round is this C1. The first round is the direct effect as 1. Second round is this, the extra increase in output give you C1 extra consumption. And then the extra consumption in C1 means extra output C1. And then that again give you the extra consumption C1 times C1. That would be the third round, right? And this will continue for many, many rounds. And then what's the ultimate impact on output? You will have to add up all this together. It sounds like a very complicated thing because you have 1 plus C1 squared plus all the way to C1 to the power n minus 1 after n rounds. But fortunately, there will be a nice formula for us. That's the sum of geometrics. Right. This gives us the limit. That is, the sum of all this is 1 over 1 minus C1. This is true whenever C1 is less than 1, right? It's geometric sum. So this property, we'll actually use it again in some future lecture. So it's one very nice way to summarize the impact of an increase in autonomous spending. That is, if there's an increase of autonomous spending by 1 unit, the ultimate impact on aggregate output will be 1 over 1 minus C1. This is generally greater than 1 because C1 is less than 1, right? Numerical example, if C1 is 0.2, marginal propensity is quite small, so you only consume extra 0.2 units. In this case, the multiplier, this 1 over 1 minus C1, we call it multiplier in this case, is going to be 1.25. That is, if government spending increased by 1 unit, aggregate output will increase by 1.25 units. On the other hand, if you have an intermediate value of C1, 0.5, you spend half of your extra dollar, multiplier in this case will be 2. And if the marginal propensity to consume is very high, you spend almost all of your extra income, then this multiplier will be really big. That shows that the higher the C1, that is when consumption is very sensitive to income, the higher the C1, well, the lower the denominator, the higher the multiplier, right? When consumption is very sensitive to aggregate income, to disposable income, you have a bigger multiplier. This makes sense, right? That is, when you have an increase in income, that trigger a lot of increase in consumption, of course, there will be bigger impact on output. So that's a bigger multiplier. And what is your marginal propensity to consume? If you have $1 extra, maybe 100 extra dollars, will you spend like all of it? Or 120 using your credit card? Or what? The average Australian marginal propensity to consume is about 0.5. So are you a typical Australian household? Spend half of your extra income. So this multiplier is a very important parameter in the short-run macroeconomics because it directly governs the response of output to any change in autonomous spending, right? We take the increase in government spending as an example, but you can imagine that if there is change in taxes or change in C0, that would trigger similar impact on output, right? So far we have reviewed we have learned some features of this aggregate demand and goods market equilibrium condition. Now we want to show you that there is an alternative way to represent this equilibrium condition. So far after this more than 30 minutes of lecture, if I ask you, what is the equilibrium condition in goods market? What is it? It should be demand equals output, right? Z equals Y. That's the equilibrium condition. What we want to show next is there is an alternative way to represent this condition. Now, let's take a look at this, the definition of saving. We haven't mentioned saving at all. And saving is defined, again, look at this triple line here. That means the definition. Saving, aggregate saving, or here, in particular, private saving, that's kind of saving by households, consumers, is defined as disposable income subtracted by consumption. In a very simple world, if you have like $10, like people have $10, they want to consume, say, $5, the rest will be classified as private saving. And remember that disposable income is defined as output minus taxes, right? Whatever you pay after tax income. In aggregate is Y minus T. So that saving is Y subtracted by taxes and consumption, private savings. I argued before that the goods market equilibrium condition is Z equals Y, which is C plus I plus G. Now, if you substitute this equilibrium condition into using this equilibrium condition, plug it back into the saving equation, substitute Y by C plus I plus G, what do we have? Saving equals C plus I plus G minus T minus C. And then we can cancel C, right? And then what we're left with is I. Let's move taxes and government spending on the other side. Saving plus T minus G, right? So we use the equilibrium condition in goods market and use the definition of saving, and turns out we are left with another condition. It says that investment equals private saving S plus taxes minus government spending. What is that? We can define taxes minus government spending as public saving in the following sense. The revenue for government would be tax income, right? Expenditure is the spending, G. So taxes minus government spending would be the saving by the government. That's why we call this term public saving. In particular, if taxes is greater than government spending, T is greater than G, we say that there is a government budget surplus. Government has more income than its spending. On the other hand, if taxes is less than spending, government spending, T is less than G, then the government has a deficit. Now, we find that the goods market equilibrium condition leads to this following condition. Investment equals private saving S plus public saving. So investment equals saving. So these are two equivalent ways to represent goods market equilibrium condition. We show that Z equals Y thing leads to investment equals savings. So you use either of them, you can find the other. So one is equivalent to the other. That's why we call the goods market equilibrium condition in the ISLM model the IS curve. The name comes from this investment saving equation. Investment equals saving. So this is where we get the name IS curve, investment saving. Now let's think a bit on a special topic. That's kind of application of what we learned so far. So far we argue that in a very simple scenario, we have output equals this multiplier times this autonomous spending, right? In a very simple case. And think about it. So what we can do, what we can't do after learning the theory. Like, nominally, it seems that the size of government spending or taxes, this could directly influence aggregate output or income, right? In particular, if the government, say, want to stimulate the economy, it seems it can choose the right size of government spending to determine the size of output, right? The question is, does the government really have the freedom to do that? Is that a good way to stimulate output? Well, our simple theory suggests it seems to be like the size of government spending will determine the size of output. But we'll give you some caution here. This is a very simple model. It will give us some implication of goods market equilibrium condition, but it's still early to draw the conclusion that government spending itself can determine output. Why? Because in practice, if you work at a central bank or any government agency, you should be very cautious to say that we should manipulate government spending to determine output, because in practice there are a few issues. First, if you want to know the exact increase in output, you need a precise estimate of this marginal propensity to consume, right? But this is quite hard, especially in aggregate. This is a hard job. And second, what happens is if the government say really will increase government spending or decrease taxes to stimulate output, but in practice, it matters whether this type of policy is temporary or permanent. Because for temporary policy, probably it's fine that you have an increase in government spending and everything else stays the same. You have some increase in output. But what if the policy is permanent? Like if government permanently decrease taxes, then what happens is that might trigger some change in the consumption behavior, right? So the implication from temporary policy versus permanent policy would be different. So this type of assertion, government spending can directly influence output, that hasn't taken into account of the horizon of the policy. And third, we haven't put the supply side of the economy into the picture yet. This is only for the short run. Government spending has an impact on output. But over time, if you stimulate too much of the economy, there will be a lot of demand. You might have heard the term like overheat. The economy might be overheated. That might lead to an increase in price level because there are a lot of demand chasing for goods. So that push up the price and cause inflation. And lastly, if government increase spending too much, you can imagine there will be a lot of debt to serve in the future, right? It's interest payment, and also the private spending might crowd out public spending might crowd out private spending. This is what we'll show in the next few lectures. All in all, there are a lot of problems with directly using this as a policy recommendation. So what we've learned so far is a simple model to see how output is determined, but don't use it yet as a policy recommendation. Now, next, let's move closer to the IS curve. So far, investment has been exogenous. We want to make it endogenous to derive the IS curve. What we assume is that investment is a function of aggregate income, Y, and interest rate. Does it make sense? Well, the idea here is similar to consumption function. You think about what determines aggregate investment, what determines aggregate consumption. The idea is that suppose you are firm owners, you operate a firm. Would you choose to invest more if the economy is in a boom, like in a good condition? Probably yes. That's the kind of argument behind this B1 is bigger than 0. That is, if you know the economy is performing well, it's probably a good time for you to invest because you know that people will buy more, you can sell your product, let's invest more, make more investment. Investment is positively related to aggregate income. In good economy, you make more investment. Second assumption, investment is negatively related to interest rate. Remember, this investment is really not financial investment. The way it is related to interest rate is the following. If you are a firm owner, you want to make any investment, you probably need to borrow or just raise the funds in the first place. Like this interest rate exactly represents the opportunity cost for you. If the interest rate is really high, it means that it will be really costly for you to raise investment. You want to buy new equipment, you want to buy new computers, desks, and chairs. All this needs resource, right? If interest rate is really high, it means that you need to incur a lot of cost to borrow this money to make investment. That's why generally we think that investment is negatively related to interest rate. The higher the interest rate, the less people want to invest. People are more reluctant to invest. So investment determines negatively on the interest rate. B2 is positive, so minus B2 is negative. Now, let's use the previous goods market equilibrium condition to see now what happened to output. Remember that we still have that equilibrium condition in goods market. That is Y equals C, which is C plus I plus G. Now we have two endogenous variables. One is consumption, second is investment. We used to have only one endogenous variable, consumption. Now we have two. So we want to plug C in and also plug I into the goods market equilibrium condition. This is what we have. This is consumption. This is investment. Now, it seems again we can solve for the equilibrium output, right? Using the equilibrium condition Y equals C plus I plus G, putting in C, putting in I, you can again solve for the equilibrium level of aggregate output or income. The only difference is now, instead of investment, we have this function of investment. Here, interest rate enter into the equation. What does it imply? It means that when interest rate is higher, equilibrium output will be lower. That's exactly what the IS curve describes. The IS curve, the first building block of IS-LM model, describe equilibrium in goods market. That give us all the combination of interest rate and output that are consistent with equilibrium in goods market. In particular, the higher the interest rate, the lower the output. You can imagine that if we were to plot this IS curve in the space of interest rate and output, it will look something like that. If downward sloping, right, with a negative slope here. So this is the first building block of the ISLM model, the IS curve. It tells us the combination of output and interest rate that give rise to equilibrium in goods market. And in particular, there is a negative correlation between output and interest rate. Next week, we'll look at equilibrium in financial market, which give us the LM curve. And what we normally do in lecture 2 is that I want to give you one example to show you what kind of exercise we can do using the knowledge we learned in this week. So today, this is the example. After learning the equilibrium in goods market, we can ask a question like this. Suppose that the economy is characterized by the following consumption function, maybe similar to the Australian marginal propensity to consume. This C1 equals 0.5 and C0 is 100. Suppose we have exogenous investment 50, government purchase 20, taxes 20. Can you solve for equilibrium output and equilibrium consumption? Now, how to do this question? Well, you have learned that the key thing today, please make sure you understand two things. One is aggregate demand is defined as the sum of consumption, investment, and government spending. Second thing is equilibrium condition in goods market is aggregate demand is C equals output Y. In short run, equilibrium is where demand determines output. So let's use this. That's the aggregate demand identity plus the goods market equilibrium condition, right? So I have used the two things that we have learned so far. Output equals demand equals C plus I plus G. And now we can calculate disposable income because we use this in a consumption function, which is given by aggregate income subtracted by taxes, and taxes is 20. So we can write down the consumption function like this. And now what we do is that we plug the consumption function back into the equilibrium condition. So you have this one equation and one unknown. This shouldn't be too hard for you at all. So you can solve for this one equation, one unknown, and you find that y is 320 in our example. And next, what is equilibrium consumption? Well, you go back to the consumption function, right? Consumption is a function of disposable income, and disposable income is y minus t, and then give us 300 as disposable income, and then consumption is 250 here. So that's a very good illustration of what kind of exercise you expect after learning the first week's lecture. We'll continue with the LM curve in next week. So see you next week. After you derive the consumption function, you can plug this C back to the equilibrium condition, that is y equals C plus I plus C. So if you put the exact form of C back in, you will have this equation straight here. I'll upload this solution after the lecture. And also, so this is interest rate. Very good question. For now, we don't distinguish because in the very short run, we take price as given, so we haven't really talked about inflation. There's no meaningful distinction between nominal interest rate and real interest rate. But we'll touch this point later. For now, we didn't say anything, but we'll use the notation as nominal interest rate.
Alright, I want to ask about the marginal propensity assumption.
C1?
C1. So basically the range is C1 is less than 1. Right?
Yeah, between 0 and 1.
Between 0 and 1. Okay. Alright.
Does it make sense?
Yeah, it makes sense.
Okay.
Yeah.
I have a question. I'm the actual student here, and I think like I did it last year. Could you show me like a syllabus later? Because my university told me to stay at this module, and it just seemed like a little bit pointless to me. Because like I did like LMS, like LM, IS curves, and like AD, AS models.
Okay.
But when it looks like the syllabus here,
Okay, I upload the syllabus online. If you have access to LMS, you'll be able to find
I've
it.
seen it, but I mean like it's very basic. I just don't understand the point why I should stay here. I just want to see for myself if there will be anything new.
Well, first, it's not up to me to decide whether you should be here or not because it's your university's decision, right? But I mean, this is the first lecture. We'll go deeper because this is only the first week. We can't throw everything to you yet. I think one good way is, if you want me to check, you can send me maybe a syllabus of your module, and then I can take a look and see if there is a lot of overlap between our intermediate macro. What's your subject called? Is it intermediate macro?
It's just called macro one. But we have 3 levels, not 4 levels.
Okay, I see. Here we have 3 levels. It's intro, intermediate, and
I can do it right now.
You can send me an email, and
I'll
take a look. And if you want me to kind of prove to your host university that you are doing something that you have already done, I'll take a look at your module and then make a judgment.
All right. So you are the coordinator of the subject, right?
Yes.
All right. Thank you very much.
Take the photo of the solution.
We'll post the solution on LMS. Yeah, you can find it.
About the equation you were talking about near the end of the lecture.
Right.
So it's like we're talking about I is equal to B0 plus B1 times 1.
Right, investment.
That equation. I was wondering that like we know that this is the equation we learned from the past. So like if we are like in the future job we are creating like some models about the equations. Is it possible time? Is that compulsory for us to like we have to balance the unit in both sides? Because like for this equation we have like the amount as for the output, but for the unit of the interest rate is not like that. So it's like the unit in both sides are not balanced.
Well, I think that doesn't matter too much. It's more like a behavioral relationship. It's more like economists will try to estimate like how this is not an identity. This is not like aggregate demand equals C plus I plus G. That should have the same units because there is more like identity. It's true no matter what. But what we did with the investment equation, it's more like a behavioral assumption. We just want to know in general how investment depends on output and interest rate. So B1 could, is it B1 or B2, sorry. B2 could be anything like depending on the estimate. It's more like, have you learned econometrics? Any like quantitative method?
No, I didn't do that.
Okay, I see. So how does it?
I was just like in the last year I was building one model, but
We can talk outside.
the lecture said that like for a practical model,